Price prediction with Facebook's profit. First, we import a few Python packages. You can attempt to pip install underscore in a cell. Sometimes it works nicely. This code imports necessary libraries such as pandas, profit, matplotlib, and pandas.ta. It also imports the AlphaVantage API package. The code is likely using these libraries to work with financial data and perform technical analysis or forecasting using the profit library. Next, we need to get some data to work with, using AlphaVantage's free API. You'll need to go to their website and get your own API key, entering it below. Adjust the export underscore path for the data to somewhere you can manage in your environment. I'm using the downloads folder. The symbol equals CW is how you pick which ticker you are trying to analyze. DA stands for daily adjusted data. PREDPER is how many days ahead, periods ahead, to give a predicted value for. This code retrieves stock market data for the ticker symbol CW from the AlphaVantage API. It exports the data in CSV format to the specified path. The code then sets the index of the data frame to the date column and prints the shape in the first few rows of the data frame. The table above shows the very beginning cells in the data frame, similar to an Excel table. Columns are labeled across the top. As a matter of good housekeeping, we're going to fill any not applicable fields with a 0, which helps avoid computational errors that are hidden deep inside a CSV file sometimes. This code fills any missing or NaN values in a data frame, represented by the variable df, with the value 0.0. The in-place equals true argument indicates that the changes should be made directly to the original data frame, rather than creating a new copy. Next, export the data frame to a CSV and store it in the folder you've been using. This code exports a data frame named df to a CSV file named preceded to cw.csv. The file will be saved in the specified directory c:/users/andy/downloads/single quote with the columns labeled as headers and the index column labeled as date, then read it back into work with the CSV file as a data frame. You will notice the use of usicalls to only utilize the date stamp and the close price. This is to help mesh the file with FB profit properly. This code reads a CSV file from the given file path and extracts the date and close columns using the usicalls parameter. It then displays the first few rows of the data frame. The code df.tail retrieves the last few rows of a data frame or table called df. It is commonly used to quickly inspect the end of a dataset and to check if any recent updates or changes have been made. Now we have to rename our columns in our data frame to appease the profit. This code assigns the names ds and y to the columns of a data frame, most likely named df. The column names represent the features or variables in the data frame, where ds likely represents the date or time variable, and y represents the target variable or the variable of interest. Here is where the magic begins. Below is a model utilizing profit, and someday I'll update this to better explain what is exactly going on inside. Their docs are pretty good and loads of people are talking about this package. Most people were able to dramatically improve predictions with a number of simple tweaks beyond the default settings of their example notebook. The goal will be to add a floor and ceiling to the prediction in order to prevent it from thinking it can predict negative values or price drops in excess of 60% within a day, for example. This step can take a minute or two depending on your hardware. This code initializes a model called profit and sets various parameters such as growth type, change point prior scale, seasonality prior scale, holidays prior scale, and whether to include daily, weekly, and yearly seasonality. It also adds for additional seasonalities, monthly, daily, weekly, and quarterly. Finally, the model is fitted to a given dataset. Fitting is literally that simple. Now, let's add cells to put our predictions into. You'll notice the date stamp is ahead by the PREDPER prediction period you chose earlier in the notebook. This code creates a future data frame with a specified number of periods in the future and then returns the last few rows of the data frame. Now we need to produce a forecast from our data. This code uses a trained model M to make predictions on future data. The predict function is called on the future data to generate a forecast. The resulting forecast is then displayed, showing the predicted values, YOT, and their corresponding upper and lower bounds, YOT underscore upper and YOT underscore lower, along with the timestamps, DS, for the most recent entries. Let's plot this data. The code generates a plot using the forecast data and assigns it to the variable figure 1. This code creates a figure called figure 2 that plots the different components of a forecast. The m.plot underscore components, forecast, method generates visualizations of the trend, seasonality, and other components of the forecasted data. We'll add an interactive plot with Plotly to show off a bit. This code uses the Facebook profit library to plot a forecast using Plotly. It initializes the Plotly offline mode and then generates a Plotly figure with the forecast data. Finally, it displays the figure in a notebook using the applet function. We need to create a second data frame, df2, to pull the stock info back in again separately from the original data frame so we have a fresh copy to work with. This can probably be foregone in future versions of this notebook, but it was helpful during the initial setup of everything to separate this out. Note the differences of df2, closed 2, etc. This code retrieves daily adjusted stock data for a given ticker symbol. It sets the index of the data frame to the date and drops the columns for dividend and split underscore coefficient if they exist. Finally, it creates separate data frames for the open, close, and volume columns of the data. Now, we need yet another data frame to pull in our forecast data and cut off the future dates. This is for the trend_return function. If the date stamps differ between the two, then it fails to analyze properly. This code extracts two columns, DS and YA, from the forecast data frame and creates a new data frame called DF3. It then displays the last few rows of this new data frame. Above you can see dates are well beyond the current date. iLock takes care of this for us. Predper is the marker to select the data from the bottom of the data frame, for predper values from the bottom. So if the prediction is 60 days, then this removes the bottom 60 pieces of data, matching the date stamps of DF2 so the two can be compared with trend_return from pandas TA. This code is manipulating a data frame called DF3. 1. The first line removes a specified number of rows from the end of the data frame using the iLock function. 2. The second line renames the columns of the data frame to date and close. 3. The third line sets the date column as the index for the data frame. 4. The last line displays the last few rows of the modified data frame. The code df2.tail returns the last few rows of the data frame df2. Above you can see df2.tail and df3.tail have the same date stamps, so we're ready to go. This code defines a function called strati that performs a basic analysis of the closing price being greater than each moving average. It takes an optional argument cumulative which defaults to true, and another optional argument last which defaults to the length of a data frame called df2. Within the function, it retrieves the closed column from df2 and assigns it to closed2. It also retrieves the closed column from another data frame called df3 and assigns it to pred. The function then creates a new data frame called tdf2 which calculates the trend return based on whether pred is less than 0.95 times closed2. The result is stored in a column named pred.name, cum log ret. The function then sets the index of tdf2 to be the same as the index of closed2. The function extracts the last number of rows from tdf2 and assigns it to window. Finally, the function plots an area plot using the data in window and adds the necessary titles and styling. The last line of code calls the strati function with last set to 2000, showing the last 2000 days of activity in the plot. And there you have it, we take the cumulate return of the logic detailed in tdf2. This calculates the return as if you held while this condition was true. There is a lot of interpretation and understanding for this particular result plot. We are working on a better means of backtesting at this time, but for now, this will have to be the general indication of how the logic can or can't produce a profit. Try messing with the pred.95 closed 2 in different ways to see what happens. This notebook runs start to finish in 3 minutes 53 seconds on my MSI laptop with an i7 processor. Please be careful when considering using this. While this is a fun exercise, by no means is this any sort of guarantee to be a profitable or successful strategy.